slope, the first thing that we're going to do is define what is rate of change. So our definition of rate of change is it is a ratio, remember a ratio can be written as a fraction, that shows how one variable changes with respect to another. And on a linear graph, that's called the slope of the line. The slope is going to be written as a ratio of the vertical change, which will be rise, to the horizontal change, which will be the run, between any 2 points on. Okay, so our ratio is comparing the rise to the run between any 2 points on a line. This remains constant or the same for any 2 points on the same line. Slope is written as a fraction in simplest form, and the variable that we use for slope is m. All right, so we will be looking at 4 different types of slope throughout this school year. The 4 different types will be positive, negative, 0, and undefined. Okay, so let's look at what a positive slope would look like on a graph. Positive means that it's increasing. So if you think about reading a graph of a line like you read a book, we go from left to right. And because this is positive, it should be going up as I move from left to right. So that is my positive slope. Negative is going to be the exact opposite. From left to right, it should be going down. My 0 slope, it doesn't rise any, it goes straight across. This is a horizontal line, and if you saw the ratio of this, it would look like some number on top of 0. All right, some number, oh, I wrote that backwards. Let me try that again. It would be 0 divided by some number. Okay, 0 divided by anything is still going to be 0. And then finally we have undefined, which is going to be a vertical line, and that is going to look like some number divided by 0. And just remember that we did talk about in class that we cannot divide by 0. So that is where we get our undefined slope from, is when we divide by 0. All right, so we've got a basic idea of our different types of slopes, and I do know that this is all review for you all. I know that slope is a big deal in the 7th and 8th grades, so we should feel fairly comfortable. All right, let's go down and look at these examples, but before we jump into the examples, I want you to notice the notes that I have over to the left. In yellow, I have how to find the slope of a line, where we do rise, so we go up and down, and then we do our run, which is left to right. And this is where a lot of students run into some trouble. To plot a point, you can see in blue, is the exact opposite way. To plot a point, we move on the x-axis first, and then we move on the y-axis. So you might want to pay extra close attention here because it can get difficult when you start mixing these two things up, okay? All right. So let's go ahead and start example 1. I see a line, and I see 2 points on that line. Right here is a point. Let me make that a little bigger. Right there and right there, okay? What I like to do is always start at the left point and move your way to the right point, okay? So the one on the left is right there, and I am going to make that smaller. Okay, I am going to start at that bottom point, and I am going to rise up. And it looks like I'm rising up 4 places. So rise 4. And then I'm going to move, since I went up, it's a positive 4. Okay. Then I'm going to go to the right 5. So when I move to the right, it's a 5. Okay. And then finally, what I want to do is, if possible, reduce my fraction. 4/5 does not reduce, so I just keep my slope as 4/5. And that's it. Let's look at example number 2. I'm going to start with the point that's on the left, and it's right there, and I'm going to count up how many spaces is that. 1, 2, 3, 4, 5, 6. Okay, so I rise 6, and then I run 3, and then I've got this sign here that says reduce. 6 divided by 3 is 2. And that is my final answer. If my slope simplifies to a whole number, it's okay to just leave it as that whole number. You do not have to keep it as a fraction. Let's start example number 3. So the point on the left is right here. In order to get to the other point, I actually have to go down. So my rise, because I went down, is a -2. And then I'm going to do my run, and I'm going over 6 places. So that's a 6. And -2 divided by 6, when I reduce that, will give me -1/3, because 2 and 6 are both divisible by 2. So my slope is -1/3. And so I do want us to stop here and talk about looking at our slope. Okay? I could have told you in number 1 that because my line from the left to the right is going up, it's going up, that my final answer should have been a positive slope, and it was. Same thing in graph number 2. From left to right, it's going up, so it should have had a positive slope, and it does. But when I get to number 3, from left to right, I am going down. So I should have had a negative slope, and I do, okay, because it's going down. So if you could predict the outcome in number 4, what kind of slope do you think my final answer will have? And it should be a negative because I'm going down, okay? So now let's find out. We know we're going to have a negative slope in number 4. Let's see exactly what it will be. The point on the left is right here, and I am going down 7 places. So down 7, and then I'm going to go over to the right, +4. +4. So my final answer will be -7/4, because that does not reduce. And that's it. Let's go take a look at example 5. And I'm going to draw this line just a little bigger so that we can definitely see it on my screen. In example number 5, I'm going to show you how we can still try to do the rise and the run, okay? But I'm going to have to just pick some random points on this line. So let's pick that point and that point, okay? If I were to do my rise, 1, 2, 3, 4, 5. So my rise is 5. And then to get to that point, did I have to run at all? And the answer is no. I did not have to go left or right to get to that point. I just kind of landed on it when I went up 5. So in this case, when you don't go left and you don't go right, your run is 0. And so what is it called when you have a number 5 divided by 0? And the answer is undefined. All right, now that we've done example 5, I want you to go ahead and pause the video and work on examples 6, 7, and 8 on your own. All right, take a minute, look through my numbers 6, 7, and 8. Some of you, you're probably struggling the most with reducing your fractions. So just make sure that you can find a number that both your numerator and denominator are divisible by. So for example, in number 6, 4 and 8 are both divisible by 4. So 4 divided by 4 is where I got 1. 8 divided by 4 is where I got the 2 from. Okay, so just think about numbers that are divisible by a number in common, and that's how we're going to reduce our fractions. Let's take a look at number 9. It's somewhat similar to number 5, except that it's not going up and down. And there's not 2 points identified on the line. So the first thing I'm going to do is just quickly identify 2 random points on that line. Okay? And then I am going to try to do my rise and my run and see how to get from one point to the other. In this case, in order to get from the point on the left to the point on the right, I am not going to rise anything because they're on the same exact line. So if I went down or if I went up, it wouldn't help me get to that second point. So my rise in this case is 0, and then my run is going to be over 6, so run 6. And then, of course, I'm going to simplify that. 0 divided by 6 is going to give me 0. So my slope in this case is 0, which is a horizontal line. All right, now that we're doing pretty good finding our slope from a graph, let's come over here and think about how might we find the slope if we're given 2 points. There is a formula for that, the slope formula. It is still rise over run, just like it was when we were getting the information from the graph. We would do the rise number first and the run number second. But in this case, we are going to use the formulas, okay? So I'm using red to represent my y values and blue to represent my x values, okay? So we're just going to jump right into example 1 here. I am going to underline my y values in red, and I do understand that it says y2 and y1, but it does not matter which order you choose to do them in, so long as you always, whatever order you do the y values in, you do the same order with the x values, and I'm going to show you. So I'm going to do 8 minus 12 on top. Actually, 8 and 12. And then I'm going to keep the minus sign in black because that's not a part of the number. That's a part of the equation or the problem. I'm sorry, the formula is the correct word I'm looking for. All right, and then in blue, I'm going to do my x values, okay? Starting on the left and going to the right. So negative 13, positive 3, and then bring down the minus sign from the formula. And what I'm going to do now is I'm going to simplify straight across. 8 minus 12 is a negative 4, and negative 13 minus 3, remember the signs are the same, so we're going to add the numbers and then keep the minus sign, okay? So negative 16. And then my last step here is to just reduce. So negative over negative, that's going to give me a positive. 4 divided by 4 is 1. 16 divided by 4 is 4. And that is my reduced slope. Okay, let's do another one. So, red for my y values, negative 12 minus 16, and 19 minus 5. Okay, the minus here in the middle is a part of the formula. And now let's reduce. On top, negative 12 minus 16 is going to be a negative 28. And 19 minus 5 will give me a 14. And my last step is going to be to reduce. Negative divided by a positive is going to be negative. 28 divided by 14 does not go evenly, so let's try to reduce them both. Let's see, I think they're both divisible by 7, so divide them both by 7. 14 divided by 7 is 2. 28 divided by 7 is 4. Oh, and I'm silly. I guess 28 divided by 14 is 2. But that's okay, we can reduce this again. Negative 2 is going to be my final answer. Negative 4 divided by 2 is a negative 2. Alright, so we've done 2 together. If you have color pencils or highlighters or colored pens, anything to help you keep your y values together and your x values together. Y goes on top, x goes on bottom, and then we just fill them into the formula. I'd like for you to pause the video and try example 3 before you come back and check with me. Alright, so I have filled in my formula, and I just wanted you to see that I still kept the minus sign in black, okay? The reason that I do that is because this negative 10 on bottom, I have the minus sign from the formula, and the number I plugged in was a negative 10 here. And that's going to become a plus sign. 2 negatives right side by side is going to actually give me negative 15 plus 10 when I simplify that down there, okay? And then 9 minus 3 is still on top. And then let's go ahead and finish simplifying this. And again with example 4, I've got minus a negative, which is really going to give me 8 plus 4 on top. Negative 1 minus 8 is negative 9. And then 12 divides by 3 4 times. Negative 9 divides by 3 times. All right, let's go look at 2 examples of special cases. And let's see why they're special. We're going to do the exact same process. It's going to start out not looking any different at all. Okay, negative 4, negative 4, negative 5, positive 1, and then bring in my minus sign from the formula. Okay, 2 negatives together is a plus, so I have negative 4 plus 4, and then on bottom, negative 5 minus 1 is negative 6. Negative 4 plus 4 is 0. 0 divided by negative 6 is 0. So I have a 0 slope here. And if you remember, if I have a 0 slope, the picture of my graph will be a horizontal line like this up here. Okay, that's what m equals 0 looks like. Why don't you pause the video? I want you to try number 7 below here on your own, and let's see what kind of result that you can come up with. I'm sorry, I'd like for you to try example number 8 instead of number 7. All right, now that you've had a chance to try number 8, you should have gotten to the same conclusion that we did in number 5, and that is that the slope equals 0. I got 0 divided by negative 15, which does equal 0. Now what we're going to do is try example 6 together, and we're going to see how this is different. So I'm going to do my y values just the same, 3 and negative 2, and subtract those. And then my x values, 7 minus 7, 3 minus negative 2 should equal positive. So 5, 7 minus 7 is 0. And then 5 divided by 0 is, so let's look at this note right here. Remember that a 0 underneath means undefined. All right, and so I do want you to remember that an undefined line looks like a vertical line that goes straight up and down, okay? And that is undefined. I think about undefined sometimes as like if you can't drive your car on it, then it's undefined. So a straight vertical line might be like a cliff. A climber could go up it with some gear, but a car couldn't drive on it, okay? So why don't you pause the video, try number 7, all right, which I've already kind of started, at least drawn my arrows a little bit. Pause the video, work through number 7, and then check back with me in just a second. All right, and so you should have come to the conclusion that negative 10 divided by 0 is, just like before, because we're dividing by 0, the answer is undefined. Okay, and that should be a U. Doesn't really look like one though. So undefined. So that's our special cases with using 2 points. Now I do want to point out that let's choose an example here. I'm going to choose numbers 5 and 6, and I'm going to do them just in a different way. All right, so I've got the 2 ordered pairs from example number 5, and what I'm going to do is I'm going to plot the points on my coordinate plane. Okay, so remember, plotting points is backwards from doing slope. So what I'm going to do is I am going to go to the left 5, and then I'm going to go down 4. And there's my point, okay? Then I'm going to do the second point. Again, starting at the origin, I'm going to go to the right 1 because it's positive, and then I'm going to go down 4 and I'm going to plot a point. If I connect these 2 points, I can easily see that I have a horizontal line where the slope is 0. Okay, I'm going to do the same thing with example number 6. All right, so I've got my 2 ordered pairs, 7, 3, and 7, negative 2. So let's see, that line was, or that point was blue, that point was green. Let's do this point in red, okay? So I am going to go over 7 to the right because it's positive, and then I'm going to go up 3 because it's positive, and there's my ordered pair. Now I'm going to do my second point here, which is positive 7, negative 2, plot my point, and then if I connect these points, I can see that they make a vertical line. and so the slope will be undefined. All right, so if you remember back at example number 4, if you just look up on your paper a little bit, when we used the slope formula to find the slope between these 2 points, we got 4 over negative 3. What I want to do is just show you a way to double check your work. If you graph or plot these 2 points and then connect them with a line, then you can count your rise and run to double check that you also get 4 over negative 3 when you do rise and run, okay? So I'm going to plot these 2 points, negative 1, 8, and then I'm going to plot 8, negative 4. All right, and then if I connect these 2 points with a line, which I don't even actually need to do, but, oops, that's too big. Okay, now what I'm going to do is, let's use red. I'm going to count my slope. Okay, so I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I went down 12 and over 1, 2, 3, 4, 5, 6, 7, 8, 9. And then my rise was negative 12. My run was 9. And again, if I reduce this fraction, I'll get negative 4 over 3. It is okay that the negative is on top here, but on bottom over here. When it comes to fractions, these really are equal. They're the same thing. It doesn't matter if the negative is on the top of the fraction or on the bottom of the fraction, or I even could write it like this: 4 over 3 with the negative in the middle. All 3 are equivalent fractions. Okay? So hopefully that's a really good backup method that you can use to plot your points. Now, if you look at the numbers in example 2, and I'm just going to write them down, 19 and negative 12 and 5 and 16. Technically, you can still do the same method with these 2 points, but most graph paper that we have, unless you have an entire 8 by 10 sheet of graph paper, most graphs aren't going to have 19 spaces for you to count over to the right. So sometimes the points are too big to be able to do the graphing method. And so in those cases, you would want to be able to use that slope formula to fall back on. Okay? Awesome. All right, now let's go do our final set of examples, finding slope if they give us a table. All right, so here is example 9, and we're going to do this the exact same way that we were doing it before, okay? So I'm going to do 11 minus 1 right here and get 10. So that was 11 minus 1. So I have a 10. You just have to remember that the y value goes on top of your fraction, the x value goes on bottom, okay? So y goes on top, x is going to go on bottom. All right, now what I'm going to do is, with those same points that match up with the 2 points I used from the y value, or y side of the table, negative 6 minus negative 2, okay? These 2 become a plus sign. 2 negatives together is positive. Negative 6 plus 2 is the same as negative 4. So I'm going to put that negative 4 on the bottom. And now in my final step, what I need to do is reduce the fraction. So both of these numbers are divisible by 2. So what I will end up with is 5 over 2. And that's my slope, 5/2. I'd like for you to try number 10 on your own. Pause the video and then come back and check your work for number 10. All right, so take a look at my work for number 10. In both situations, for my y values and my x values, I had minus a negative number here in the middle. So I circled both of those and put them together because they make a positive, okay? -5 plus 2 is -3, and -4 plus 3 is -1. When I put those together as a fraction, -3 over -1 is +3. You could leave the 1 on bottom if you wanted to, but you don't have to. All right? Hopefully finding the slope from a table is really easy. Let's try number 11 together. So I've got 6 minus 6. 6 minus 6 is 0. Then I've got -1 minus 3 is -4. Okay, 0 divided by -4 is 0. And it's that simple. Why don't you pause the video and try number 12, our very last example for today. All right, so I finished finding my slope for number 12, and that reduces to just a -1. My slope is -1. Now, even with these tables, if you chose to plot the points and to count your rise and your run, you could do that, just like we did the other day with our Unit 4 Lesson 2 when we were learning about creating function tables and then graphing linear equations using the tables. Okay? All right. I hope this helps you all with your assignment that you have tonight to practice slope. Our next lesson is going to be slope applications, which is word problems. So it is important that you kind of become a master at finding the slope from a table, from ordered pairs, and even from graphs, okay? Again, you can plot the points if you want to create a graph, or you can use the formula, or you can, well, we're still using the formula from the table, okay? The most important thing to remember is that the y values, the change in the y values is delta y, that goes on top. And then the change in the x values, so delta x, is on bottom. Delta just means the change in something. All right, our video is finished.